seen that the best results are obtained if the references are nearer to the eye. For instance, the place near the eyelids, in this case, that's what helps us when the eye moves, or the eyebrows as well. How can we detect the center of the eye? As we have said, we limit the area of the blob, and then we have a blob accounting for the whole eye. Once we have that blob, it's very easy to detect the gravity center. As you can see it here with a red cross, and that's the center of the eye. Then we cross-reference this to some other pictures, and we can see what the person's looking. In this case, you can see this cross on the center of the eye, and then the next reference we compare it to. We can see this marked with a different sign. As you can see, we have to establish different thresholds, vertical and horizontal, in order to know exactly what that person's looking, and that depends on the user. And we can also detect the eye movement. It can be either instantaneous or coming back to the center. So let us imagine that we want to control, to monitor the mouse of a computer. If the person is moving his eye leftwards, we want to tell the mouse that it has to move leftwards, but that has some drawbacks. Of course, if we're looking to the screen, we're looking at the screen, and then the eye moves to our left, then we no longer see the screen. So that's not a valid solution. Then there's also another possibility, which is to go back to the center, meaning the user looks at where he or she wants to see, and then goes back to center, so that they always focus on the interface. If we want the mouse to move leftwards, we can move our eye leftwards and then go back to the center. And from that moment onwards, the mouse will start to move to our left. If we want to cancel that movement, that the person has to actually move the right to the other side. In this case, or look to the right and then go back. We have also conducted several experiments for instantaneous detection or for this type of back to the center system. The best results have been obtained with the second method, as you can see. Detection when the user is looking to the center, rightwards, leftwards, up or down. But if we analyze on this second table, the percentages are higher than 97 in all cases, whereas in the case of instantaneous detection, the worst case scenario was only in 70% of the cases, and the non-detection rate is also improved. There are some situations in which the algorithm cannot detect where the person's looking. So in those cases, with this back to the center technique, we can see that non-detection is absolutely eliminated, and the possible error is minor. I'm going to show you a little clip that explains how this interface has to be used in order to control a robot. Now, first of all, this is an application in order to check that the thresholds that have been selected are right before using the robot. So it's a very simple application. The user can look to his left, right, up, or down, and then detects that the system is working. And then we apply this to the real robot. This is the interface. On the right, this is a robot that we're using for our experiment. It's an industrial robot. And of course, the person can move his eye freely. He can move the robot, again, to its left, right, up, or down. So we need to work on the very same plane. As you can see here, we see the person moving his eye to the side he wants to direct the robot to. He goes back to center, and as long as you don't cancel that movement, the robot keeps moving that way. So it's a very simple system, and it allows us to control any type of device. Here's another example. At first, the person looks to the center, then he looks upward, therefore the robot is moving upwards, and there are incremental movements sent to the robot, which of course limits down the space, the working space. Now, let me draw some conclusions. We can see that this algorithm is quite robust. We have selected the right type of parameters. We don't need to calibrate the system to set it up once again every time we use it. And this has different applications. As I said, computer, domotic systems, robots. It's a personal aid system for people with disabilities. But before finishing, I'd like to show you another type of development that we're working on for robot control. But in this case, instead of using a camera, we are using electroculographies. So there's a pool of electrodes that are located around the eye, and they locate the eye movement. So I'm going to show you a short clip before finishing. So this would be a different way of using this system to control a robot based on ocular movements, but on the basis of this electroculography. This is the device we use to obtain the electroculographic signal. It's called a Viking system. And just as we used before, it's an acquisition card that is used. And these are the locations where the electrodes are placed. And in order to control the robot, of course, we need to use a server that receives all of the commands that are sent by the user, in this case through the person's interface, that eye-based interface. We run the server at first, we just wait until the person sends those signals. Again, leftwards, rightwards, upwards, or downwards. So that's how the server is run, the interface, the user is there, and basically the person does the same type of movements, this fast leftward or rightward movement going back to the center, coming back to the center, and then the robot moves the same way. And just as before, the user has to move his eye the other way in order to cancel that signal. We can see that in this case the system is, well, quite quick. And the main advantage that this system presents is that we're no longer dependent on the lightning, because in the prior case we needed the right type of lighting and a camera, whereas in this case we just need those 4 electrodes to detect the person's movements. Area. So in theory, you can be closer or further from the camera, and therefore the eye area will be larger or smaller, and that can also help frame the picture. And that would be an alternative. That would be a way to assess whether the person is leaning back or forth, because that might also have an impact on the image. I'm curious about one thing. Worked. Lightning is no minor issue, because right now the type of devices we're using require excellent lightning. So there might be some kind of synchronous system with a source, indeed. There are some developments with the commercial users that actually use these systems, indeed, but with this type of systems, it is only applied for multiple captures with a high degree of velocity. So they might be used. Yes, thank you. I had a similar doubt. I was thinking about using sensors instead of a lightning source to detect the degree of luminosity or lightning in an area. Yes, indeed. And that has an impact on the threshold establishment stage. And we might use that for the first stage and then just keep the black and white image for the whole process. The image processing techniques that you're using are specific. Well, they're very simple, to tell you the truth. We are fixing these type of thresholds, which is not difficult at all, and we just run the blob. We just count the number of pixels in the area. It's not a complex algorithm. No, I was thinking there might be a smarter system to use to that end. Well, maybe if we converted the algorithm, that would be a much more complex process. But what you're referring to is not the difficult part of the system. They are just arithmetic calculations. We just count the number of pixels. That's it. Okay, what about the click? Have you thought about this and what role it plays? Because you have shown the robot and how it moves, but what about the click? Well, there's a project we're working on with remote robotic systems of interfaces for people with disabilities. We're trying to improve this interface because the interface allows us to move freely, but if you want the application to a specific degree of freedom. Thank you. Any other question? Okay, then. We would like to thank the speaker for his presentation, and we hope to see further results. Thank you.